Okay, in our final part of 7.3, we're going to rationalize binomial radical denominators. And we're going to do it using conjugates. And this is a review. We've used conjugates before. The reason we're doing this is because we cannot have roots in the bottom of our fractions. We cannot have rational numbers in our denominators. So we need to get rid of that root of 3. So we're going to multiply by the conjugate. So if they give us 2 minus the square root of 3, then the conjugate for that would be 2 plus the square root of 3. And in order to keep our fraction the same value, we have to multiply the top and the bottom by the same thing. So all we're doing is multiplying the top and the bottom by the conjugate. For our top, it's pretty simple because we have a monomial over here, so we're just distributing. 3 times 2 is 6, and 3 times the root of 3 is a positive 3 root 3. So that's all we had to do for the numerator. For the bottom, we're going to FOIL just like we did before when we multiplied binomial expressions. So 2 times 2 is 4. 2 times positive root 3 is 2 root 3. Negative root 3 times 2, well, that's a negative 2 root 3. And then we have a negative root 3 times a positive root 3, because it's a negative, and we know root 3 times root 3 is just 3. So now we're going to look and see if there are any like terms we can combine in the bottom. If you FOIL correctly using a conjugate, you'll notice these middle two terms are the same with opposite signs. So those are going to cancel out. Positive 2 root 3 and negative 2 root 3 will end up canceling out. So our denominator is just 4 minus 3. And on the top, there are no like terms to combine. So I have 6 plus 3 root 3 over 4 minus 3, which is 6 plus 3 root 3 over 1 when you do the 4 minus 3. But we're okay with not even putting it over 1. If you remember that's your final answer, you'll be okay. So in example 9 here, again, if they give us in the denominator 1 minus root 5, we're going to multiply it by 1 plus root 5 on the top and on the bottom. And in this case, we have to multiply binomials in both cases, so we're going to FOIL. So I'm going to do 2 times 1, write it down here, that's 2. 2 times positive root 5 becomes 2 root 5. Root 5 times 1 is 1 root 5, and I'm just going to leave the 1 there this time because it'll help me combine like terms later. And then root 5 times root 5 equals just 5. And I'm going to do the same process to the bottom. 1 times 1 is 1. 1 times root 5 is 1 root 5. Negative root 5 times 1 is negative root 5. And again, you should already notice negative 1 root 5, that these two are going to end up canceling. And then negative root 5 times positive root 5 is negative 5. So now we're going to look and see if there are any like terms to combine. On the numerator, we have 2 and 5. Well, 2 plus 5 is going to give us 7. We also have like radicals here because they have the same index and same radicand. So 2 root 5 plus 1 root 5 equals a positive 3 root 5. Now we're going to go to the denominator and look for like terms. We've got a 1 and a negative 5. 1 minus 5 is negative 4. And again, if we did things right, these middle two terms should be conjugates. They should be the opposite of each other. Positive 1 root 5 and negative 1 root 5 cancel out. So this is our final answer.